Hello and welcome everybody. I'd also like to especially welcome the students from NTU. Today we're going to be listening to Liam Gulliver and Peter Gallagher, and they're going to be talking about controlling robots remotely with Azure. But before we get started, just want to go through a few of the house rules and let you have a moment to look at that. In the meantime, Liam Gulliver is a DevOps consultant and Peter Gallagher is a freelance programmer for PJG Creations. And we're in for a treat today because we're going to have some hands-on with remote control of a robot over the cloud. And I'm really excited myself about this. Just a few more things to go through. As usual, we've got the inclusion and diversity questionnaire. I'll give you a moment to take a photograph of this QR code with your phone or just note down the URL. We'd be very grateful if you could complete the inclusion and diversity questionnaire right away or during the presentation. Another note is take a look at the branch website. We've got lots of information in there and we're building up an archive of the past presentations that we've held in months past us. And we've also got a few items coming up for the future. And just before we jump into the presentation, just want to introduce the presentation that will be given next month. And that's another look at the IT strategy with Wardley mapping. Thank you, and we'll hand over to Peter and Liam.
Cheers, thank you very much, Gary. So let me just quickly share my screen as well so we can pop the presentation up. And hopefully you can all see that okay.
We got two lots of sharing actually. So Gary, do you want to stop sharing your screen as well?
Yep.
Cool. So thank you everybody for coming this evening, for joining Pete and I to talk about stuff that we're largely very excited about as part of our respective day jobs. Just go through a couple of intros for myself and Pete. I am, of course, Liam Gulliver. As Gary said, I'm a DevOps consultant by trade, and part of my job is also being a cloud solutions architect and a systems engineering delivery manager for a consultancy called MMT Digital. I've been working in the industry now for about 16 years across all things software engineering and DevOps. And basically, if you can attribute those two things to it, I've probably done it in the last decade and a half. I actually also organize my own meetup, which is DevOps Knots, and we meet on the last Tuesday of every month. If you go and have a look for that online, obviously please feel free to come along if you're interested in those sort of things. And along with Pete, I also co-host many different media endeavors. We have a Agile Engineering podcast, which is on all things software dev, Agile, and DevOps, along with two live shows, Azure-ish Live and Azure-ish After Dark, where we talk to folks from around the tech community, or do kind of like a scrap heap challenge-esque coding challenge each time, every other Tuesday, I think, isn't it, Pete?
Oh, well, thereabouts, Christmas permitting.
Yes. So I'm going to hand over to Pete.
Hi, I'm Pete Gallagher. There's lots and lots of words on my slide because, like Liam, I like to get involved in quite a lot. But in my day job, I'm an IoT specialist. I run my own company, so I freelance for various different companies across the world doing IoT work. I'm also a Microsoft certified trainer in Azure MVP as well. And a Pluralsight author and public speaker, and I run Knots IoT, which is an IoT and sort of high tech and sciencey meetup online now, of course. .NET Knots with Jess White, and also Knots Dev Workshop with Gosha Borcheska. I'm also a STEM ambassador and a code club organizer because I've got two little girls at home, so I'm quite well motivated to make sure that they've got access to all of the STEM stuff that they should have. Along with Liam, as well as you just mentioned, we're part of the Agile Engineering Podcast and Azure-ish Live. And on the Azure-ish Live Twitch channel, I've just started a new show called IoT with a TEA at the end, where we build real-world IoT solutions. And we've got Benjamin Carbe, Cliff Aegis, and myself this week on Thursday at 2 p.m. building a LoRaWAN solution live. So well worth checking that out, 2 p.m. GMT.
So what we're going to be doing over the next hour, we're going to take a look at the project that we're going to deploy. We've obviously had to go and do a few bits for here. Here's what we made earlier, because I'm pretty sure it wouldn't be that fantastic a talk if we were sat watching Pete's 3D printer for several hours. And then we're going to go into dotnet and GPIO on the Raspberry Pi, because we're using the Raspberry Pi for the robot. And go through how we built the robot and what it does, and then we're going to start taking a look at the robot control interface, which is going to be built in Blazor and using SignalR, and we're going to deploy that to Azure using GitHub Actions. And then once we've done all that and we've explained all those working bits and pieces, we're going to let you guys actually have a play with the robot itself from your very own homes to the one that is sat next to Pete, and you'll be able to see that live as well. So let's take a look at the project architecture. Sorry. So the first thing that Pete and I wanted to do with this was, with it being socially distanced as we are, we weren't seeing each other or our friends at meetups. So we wanted to do something really cool with it. And Pete already had a great starting point in a robot arm that he'd already built with the Raspberry Pi, as well as the many other great projects that Pete does. One of the things he's been doing lately is a Pico producer, which is basically like a build your own Stream Deck, which is really awesome. So go and take a look at that. But what we have is, I live about 6-7 miles from you, I think, Pete.
Yeah, roughly. Yeah.
And then we have Pete's house as well. And I don't generally know that much about IoT. and Pete's been really great in showing me all these things. But what I do know is .NET, and I do know Azure. So we thought, let's kind of throw these things together and see what sticks, and see if I can control something in his house. And I'm sure everybody's seen the really great demos that lots of folks do around, let's turn on the Christmas lights or a light in a room and stuff like that. Whereas we thought that was great, but we kind of just wanted to take it one step further. So Pete's got the little robot arm in his house. There's a fantastic artist rendition of a robot arm.
It's Hangman that you're drawing there, isn't it?
I'm going to deploy something, or I'm going to push something up to GitHub, which is then going to deploy to Azure, which will then talk to the firmware on Pete's robot.
I'm disappointed you didn't draw the icons for GitHub and Azure there. It's,
Going by the quality of the houses I've drawn, I thought it was probably best not to. And so what we've got then is we've got kind of two distinct components in terms of software, at least, right? So let me just clear this canvas. So we have robot control interface that we're talking about, and this is Blazor, which is all .NET, which will be compiled down to WebAssembly.
We'll talk a bit more about that in a bit.
Yep. We're going to need to, we want to do it in real time, right? So you don't want it to take several minutes for a command to be issued to it, because let's say if this was a real world scenario, and as is happening now, where you're getting things like remote surgeries and that kind of thing, several minutes is far too long for that to process. So we're going to use a technology called SignalR as part of the robot control interface to talk to talk to the robot and pass messages around between the two and feedback. And then on the robot firmware, we're going to control the mechanics, I guess, would be the right way to say it.
Yeah, that's fine. Yeah, the physical elements.
Yeah. Let's do physical elements.
Oh, should have just put kit.
I should have said just kit, yeah. And that is also going to be internet connected, obviously. Internet connected.
Otherwise, it's just OT, and that's boring.
Yes. And what we're going to want with the RCO, we want this to be a user interface ultimately, and we want this so that everybody here can use the UI to control this thing over here. I think that roughly explains it, Pete, doesn't it?
Yep, and we'll go into some more detail as we go along in the slides anyway. So, I mean, we just wanted to get the overall sort of architecture working for you on the screen there so you can see where we're heading with the talk.
We move that over here. Okay. So I'm going to hand over to Pete for this bit because he is basically the expert versus me. And we're going to start talking about .NET and GPIO.
Yeah, thank you very much, Liam. So yeah, GPIO, in case you don't know, that stands for General Purpose Input Output. And that is, if you've got a Raspberry Pi, you'll see a bunch of pins down one side, 40 of them. And each of those pins has got a function, from driving just an LED or reading a button to serial interfaces and PWM interfaces and things like that. So let's see if I can control Liam's slides remotely.
You should be able to, yeah.
There we go. So to get, or you have to start with some programming language here. And obviously, there's a whole heap of options if you're using a Raspberry Pi. You could use Python or you could use Scratch even. But .NET is where Liam and I sit for our careers. So yep. I tend to gravitate that way. But getting .NET installed on the Raspberry Pi is actually more difficult than it should be. There's no, if you use Linux, there's no apt-get install for .NET 5. If you're using something like Ubuntu, a 64-bit Ubuntu instance or something, then you can do that. But for the Raspberry Pi, there's a whole heap of steps that you've got to go through, and it's a bit of a pain. So I made a single line install script to get .NET 5 installed and configured correctly on the Raspberry Pi. So you just run that single line that you can see across the top, and then that GIF is sort of explaining what happens. It's downloading the .NET 5 binaries, the SDK, and then it'll download the ASP.NET binaries after that. And then it'll do some configurations so that everything's all linked up correctly. And then you reboot your Pi and you are off and running. And you can see there that that's showing that .NET 5.0 or 5.0.1.0 or something like that is installed. So,
sorry, Pete, wasn't there something recently that meant that there are newer ways to do this now, at least with the latest hotfix? But I can't remember. I think we were talking about it the other day where it was you don't have to do as much with your script now, but it's still fairly essential for now.
I think you still need to do all of this lot on a Pi, as far as I'm aware. There is VS Code on the Pi now, which is quite nice.
I think that's probably what I was thinking of more than anything else.
Yep, absolutely. So instead of using something like Nano, if you've used Linux, then you can use VS Code if you want. But we're not going to show that in this talk, but I have on my website, there's a few blog posts in there, and one of them is showing you how to remote deploy and debug your code from your PC directly to the Raspberry Pi. For what we're doing here, I'm just running the code directly on the Raspberry Pi, building it and running it there, because we don't want to overcomplicate things. So to interface to those pins, so you can see across the top of the Pi there, that black area with the silver pins in it, that is our GPIO section of the Raspberry Pi. And to interface to that with .NET, then we can just install a simple NuGet package. NuGet package is just a bunch of somebody else's code that we can use. And we do that with that single CLI command there, system.device.gpio. And that particular piece of code gives us access to not only just the I/O, but also SPI, I2C, and PWM, which is what we're actually going to be driving the robot with later. It supports more than just the Raspberry Pi as well. You can do the Beagle board and Hummingbird and Odroid and things like that. But I tend to just stick with the Raspberry Pi. I'm happy with that. And obviously supports Linux. And if you've ever seen, there's actually a build of Windows 10 called Windows 10 IoT, which is pretty unsupported these days. It will work with that, but I don't recommend you use it. There's not that much need anymore. There's something called Uno platform out there that lets you make graphical user interface GUI apps in .NET. It's a bit like Xamarin, if you've ever heard of that. So that's how that's working. GPIO. They're the pins you can see there, and there's two different numbering schemes, and we'll see this in the code potentially. But there's the board numbering scheme, which is what I stick to, and that top left pin, that square one, is 1, and then across from it 2 and 3 and 4 and 5 and 6, and I can count just about, and so I stick with that one. Whereas the BCM numbering scheme, that one there refers to the chip that drives the GPIO on the board. And so it's kind of a historic number, but some people might be caught up in that numbering scheme for, legacy reasons. I don't do that because I've got to convert that 14 to an 8, and I can never remember what BCM pin is on what physical pin. So just stick to the board numbering scheme and make your entire life a lot easier. We've got a bunch of servos connected to our Pi through this control board. Now, I'll explain about servos in a second, but they take a certain amount of power, and you can't connect them directly to the Raspberry Pi pins. The Raspberry Pi pins are rated at about 35 milliamps, and the servos can take about 350 milliamps if they stall. So that's a really great way to fry the GPIOs on your Raspberry Pi. So you can get this Monk Makes board. This is just one of many different ways of doing it, but this is a really good one because it means that you've still got direct control over those GPIO pins. We just connect the power separately. So you can see where I've got power and ground on those black and red wires. They're fed through just to a battery pack. And that yellow control wire, that goes through the board and out to the Pi. So it just isolates the power away from the Pi. So building the robot, device bindings and servos. So this is the overall circuit that we've got there. I don't know if we zoom in a minute. No, we don't. So I've actually got, because this is from a different talk essentially, and we're building on that talk. In that talk, I take people through the IoT Hello World, which is flashing an LED and reading a button. So the circuit I've actually got wired up includes that LED resistor and button on the left-hand side, but we won't actually be doing anything with that in this talk. Everything we're going to be doing is through that servo board in the middle, and you can see where we've got a battery pack connected to that, and then 3 servos. So them servos there are like mini motors, but they've only got 180 degrees of motion, and I'll show that how that sort of works in a minute. But we have them same servos are in that robot there. So you can see there's one at the top left, which is the gripper control. There's one at the bottom that you can see, and that's controlling the reach, so sort of forward and backward motion of the arm. And then there's one in the base. So that's the 3 degrees of motion that we've got in our particular Pi. The servo control board connected to the Pi, just with them on them same GPIO pins there. So I've actually got the ground wire connected down there, and then 3 different control pins for the 3 different servos. Now the Pi itself has only got 2 hardware PWM, pulse width modulation ports. And they're the best ones to use because we just tell the Pi what to do with those, and it does it. To get any more than that, you have to do something called software PWM. And sadly, the .NET library is rubbish at software PWM. So I've connected that software PWM port to the gripper, the pincer part of the robot, because we don't really care if it's like an on-off action, and you'll see how that works later.
So Pete, I've just got a quick question.
Go on.
So, and it might be something that not everybody else has noticed, but I'm 2 foot away from the slides in front of me. So, on this screen, our example has got a Raspberry Pi 3B.
Yes.
On an earlier one, we're looking at a Pi 4. Does it matter which one somebody uses?
No, they'll both work. Unless you go back down to something like a Raspberry Pi 2, then you'll struggle. But a Raspberry Pi 3B is perfectly fine. A Raspberry Pi 4, it's just going to make your experience better, because if you're going to build .NET code on the Pi, then the relative speed of the processor of the Pi itself.
A bit more oomph behind it.
Exactly. But it will work perfectly fine on just a boggy standard Raspberry Pi 3. It's just it's going to take longer to do everything. But once it's up and running, it will work exactly the same. It's just not got the processing power that the Pi 4's got. So good point. Absolutely. It's worth pointing out on that particular diagram as well, the badly labeled pins on that servo control board, where you can see the GND, the upside down GND, and then you've got channel above that, and then 1, 2, 3, 4, 5, 6. I plugged everything in wrong first because I found that quite a bad label. That ground pin is the one black connected to it there, and then channel 1, 2, 3, and 4, and 5, and 6 are in line with the pins. Yeah, I wouldn't have done it that way, I don't think, but never mind. Also on the Raspberry Pi 4, there's 2 HDMI ports, and they've labeled them 0 and 1. That's great if you're a programmer, but if you're a regular person, you'll just see HDMI 1 on there and plug it in there and wonder why your screen doesn't work. There's a few things that happen in the world that I would probably change. So servos here, I've got a little GIF that I made earlier. So they work on something called pulse width modulation. So this is coming out of one of those pins on the Pi, the hardware PWM pins or the software one that we're doing. So if you send pulses that are quite narrow, the servo will move one way. If you send pulses which are sort of a reasonable distance apart, then it'll move to the center. And if you send longer pulses, then it'll move to the other direction. So that's the basic idea of how these servos are working. You literally just pulse a pin on and off with a certain pulse width and a certain frequency, and you'll move that servo to a particular position. And you can see that it starts at, say, that's 0, and then up to 90, and then it'll go down to 180. And that's these particular servos, they're 180-degree servos. That's their full range of motion. It's as much as you're going to get out of that. So I thought it's often quite handy to explain it that way. I was explaining this with just hand signals, and it doesn't get over the same point. So that's how that's working.
You can get servos that do a wider range of motion, right? Like if you wanted to pay the extra for a 360 one, perhaps.
Well, yeah, but you wouldn't want to do that because they're continuous motion servos at that point. And you're controlling the speed of the servo rather than the position, if you will, I think.
Right, okay.
As far as I remember. But either way, yeah, you don't want the robot arm to be able to move at 360 degrees because it'll just break.
Fair enough. Yeah.
That's the actual point. So at that point, I'm going to flick over to let Liam talk about Blazor with SignalR. This is both our expertise areas, but in the interest of fairness, let's let Liam do something.
I mean, you can carry on talking if you want, Pete.
No, I'm going to go get a glass of water.
So, as I mentioned at the start, we're looking at building, we have built interface for the robot control using Blazor for the front end, and we're going to make all the code for this project available to you all at the end of this as well. We'll send some links to Pete and Bev, and you'll be able to grab these to your heart's content. But Blazor is essentially a project that started as a little open source project by Steve Sanderson. Ultimately, it means that we can write UI in C# just directly without having to do anything other than worry about writing HTML, and we don't have to write any JavaScript, but we can use JavaScript if we want to with interoperability. I guess from our point of view, Pete, because we're not particularly front-end developers, we found it easier to use overall versus something like React or Angular, because we know C# and we don't have to swap languages or thought processes behind it particularly. It already uses well-established conventions such as Razor from ASP.NET MVC, and it also means that you can do sort of two things with it. Now, I mentioned earlier that it compiles down to ultimately WebAssembly on the client end, but we have two kind of hosting choices. We've got server side where we can almost run it like a standard ASP.NET MVC app in a way, where we have our front end and then we have our back end all together, or we can go to something that Pete and I have also done along with another host of ours on Azure Live, Jonathan Ralph, where we've built out a completely serverless application that uses client-side WebAssembly and then goes off to function apps. And that basically means that we've managed to write a complete static site in .NET. And then we've hosted that out of an Azure storage account rather than paying the many hundreds of pounds it can be to run, say, in a VM or in app services. And we can run that directly in the browser without having to have any add-ons for the browser, without having to install any additional plugins. It kind of just works. I think is, now I've said it, it's probably going to go horribly wrong, but
what we're doing here actually is a combination of those two types of technologies. There's a third type there that we're actually using, where it's called hosted client-side WebAssembly. So you have a server side that we have sort of the main control hub for SignalR hosted in, and then you still have the client side that goes down and connects back up to that server. So we're combining those two technologies to get this to work.
And the great thing about it is basically, as long as it's a browser that's been out in the last 2-3 years, I think it is, Pete, or it may be a bit longer than that, it's fully supported, because while it is running WebAssembly, there's still a JavaScript file that it compiles down to when it comes to the client-side stuff, which is supported by all browsers. And then we were talking about earlier the real-time communication piece. So we're using a technology called SignalR. You can use that in Azure if we wanted to. There's a serverless option where we can use the Azure Signal service, but we aren't in this instance. We're actually hosting this in our server side of the Blazor piece. Again, it's another Microsoft technology that's completely open source, and we can have multiple clients connected to it and send messages out to them, and they can send messages back to the server, all in real time, either over WebSockets or through long polling, or you can send events directly from the server. So it could be, for example, let's say we wanted a notification to pop up from the server, we could actually put a message through the SignalR hub, and it would pop up on everybody's UI. So I think we probably want to take a look at the code, Pete.
Let's do that.
So we can take ourselves through what that looks like. So do you want to talk about the robot firmware first?
Yeah, I'm going to do, start with that. Yeah, so if I scroll up to the top, so there's a few things in here. The one that I started out talking about, we've actually left out now, but the system.device.pwm, this is where we're controlling that pulse, if you remember, for my little animation there. And then we've got drivers as well that we're using. But we're also using iot.device.servomotor. So there's a second library that we can use called the IoT device bindings NuGet package. And that device bindings NuGet package contains a whole heap of somebody else's code. And one of the pieces of code in there is servo motor control. So it's all right knowing PWM, but that's all about frequencies and pulse widths. Really what we want is just tell the servo motor to go to a certain angle. So that's what this particular stubby piece of code is giving us. But that library gives us access to a whole heap of other stuff like IO expanders and serial interfaces and things like that. So it's really handy. And yeah, do go and search up the IoT device bindings NuGet package, and it'll tell you a bit more about it there.
So
and then,
just to be clear, then, so on the IoT device package, we can do more than just stuff with servo motors. It can be a bunch of other stuff.
Yep, absolutely. And it's great because it just gets you off that starting block. So there's regular motor control in there. And as I say, there's IO expanders. And there's about 30 different devices you can interface to. There's a Raspberry Pi hat hardware attached on top. So then pins, you can actually get boards that connect to it. And there's one called the... what's it called? But it's part of the AstroPi project. So it's a little board and it's got some LEDs and a couple of buttons and a little joystick and magnetometer and a gyroscope. And there's two of those, Sense Hat, and there's two of those gone up to the space station with Tim Peake when he went up there. And children can run experiments on the space station and the AstroPi project once a year. It's really cool. As soon as you tell anybody that they can do experiments in space, then their eyes light up. Certainly if you're a big kid like I am. So below that, we're bringing in the SignalR client and also HTTP, which is what it's going to be talking over. You don't need to worry too much about understanding the code, but the blocks are relatively important. So at the top here, we've got this hub connection, which is the SignalR hub. So this is where we're connecting to that SignalR client in the cloud, and we configure it a bit later on. Next up, we're configuring some PWM channels. And that takes some parameters that we don't need to worry too much about. But once we've created that PWM channel, we can create a servo motor, and we can pass in that PWM channel into the servo motor, and then we can specify its degree of motion and then its minimum and maximum pulse width. Now, depending on which servo motor you buy, you might need to play with those two figures just to get it to go to the right angles.
Would they not be documented?
No, will they?
Oh, okay.
Good luck. Yeah, and you can buy like these servo motors are like 50p for a bag of 10. They're throw them away.
I
when
wouldn't
it's not
expect
working.
much documentation for
No,
that price.
The documentation is thank you for buying these. So that's fine. So we've got 3 PWM channels here. This is the second one. And then you'll see the third one is using something called software PWM. It looks similar, but this is Microsoft's attempt at making that PWM in software. Now, this isn't a Raspberry Pi is not a microcontroller. It's a full computer, and it runs Linux, Debian Linux at that, Raspberry Pi OS. And trying to do anything with software PWM when you've got an operating system in the way is difficult. Funnily enough, the Python stuff manages to do it. It's just that the people who created this .NET library, I don't know whether they've made a very good job of it or not, but it doesn't seem to work all that well, and you'll see that as a result. But we can pass that software PWM channel into a servo motor because it's a separate piece of code, and then use it. And you see, I've tried different figures here, and none of them seem to work very well. After that, we just start up the servo motor control. So that just binds that together. And then after that, we're talking about SignalR. So here we're creating a new hub connection. And at the moment, we're binding that code to a local IP address because you can run all of this software locally. So that's the IP address of my PC here at home. And I don't mind sharing that because it's not IPv6. So you don't know anything from that. But we get a port number and then this chat hub. We've got a bit of configuration here. And that's because when we connect to another computer, it might complain about the certificate. And I couldn't be bothered setting certificates up properly just to get a demo to work.
Yeah, for the purpose of this demo.
Yep. So it does say, it does preface this with dangerous. So yeah, that's going to accept any certificate, which you shouldn't do in production. But for the purposes of this demo, it's fine.
Yeah, it very much if this was a robot arm that was a life-critical piece of machinery, we wouldn't be doing that.
Yeah, there would also be a lot more code.
Yes. Yeah, absolutely. Yeah.
Yep. So on that particular note, this line here makes sure that a bit later when we push up the latest version of the code, it will reset the little virtual machine that the server code is running in. And when it does that, if the robot is running, it will lose its connection. So that line just makes sure that it reconnects when it needs to. And then we build the connections that creates that connection. And then underneath here, we've got the connection itself. And there's for SignalR, it's messages. If you think of SignalR like a really good way to do a chat room. So you have multiple things, people, connections, all to a single point, and they can all talk to each other. So they send messages and they can receive messages. So in the web code in a minute, you'll see we're able to send a message out, and we call that message receive message. The problem is that when you've got sending and receiving, depends on where you are sending and where you are receiving as to whether or not it makes sense. But we are receiving the message down here, and we based this on a simple chat app. So the user, as it would be, so it could be Pete or it could be Liam, but I'm calling it Servo 1. He sends the message with the user in there and the message. And we take that message and we convert it to a number. And then down at the bottom of my code, I have a move to angle down here. And I literally just do servo.right angle. And I'll just tell it to move to that particular angle. So this part of code is coming from that IoT device bindings. This just makes my code a little bit prettier when I do it this way. So it takes that servo in, writes the angle that I pass into it, and it just does it. So it just makes the code a little bit better for me, which is nice. And then the rest of it is just a loop here, because otherwise, because this is all asynchronous, if we don't get a message immediately, the code will just stop. So I stick that while true in there, and we can exit then when we want. So that's the robot firmware side, but we've also got the robot web side, and this is the part that contains the Blazor and SignalR code. So in here we have the client and the server, and we also have a shared folder. We won't do anything with this, but what the shared directory or project lets you do is share things like models And
we've just
this
used
code,
the what do you call it for this, haven't we? The default template scaffolding that you get when you set up a new Blazor project. We've not taken anything out of it. We've just added our bits to it for now.
Yep, I specifically did that because to create a new Blazor project, you just do .NET new Blazor WASM. And I've stuck this -- hosted on the end of that to give us these 3 different projects. And you can share things like models here, so entity models here. So their original sample there contains a a weather forecast that you can grab yourself and do something with. So that's what the shared thing is. We're not doing anything with that whatsoever. Then we've got the client side, which is what actually runs down on your PC. And we have the notion of pages here, and we've got an index page. And this is where all the
control...
control...
through this little bit, Pete.
Sorry? Yeah, absolutely.
This little bit?
Yeah. So this is where the control is that you'll see on the UX. And yeah, Liam will explain how this bit's working.
But purely handing over this because this is more or less Pete started it, and then I went and changed a load of the code. So what we have is you'll see shortly we're going to have a iframe that's going to actually show the robot arm itself, and we're going to list out all the messages that it receives. It won't display ones that I send, but when someone else sends them, then we'll see those messages that have been received. We'll see our servo controls, which will be some sliders. In fact, let's go to here.
Oh, look at this!
In fact, looks a little bit like this. So that's live right now behind Pete in his office at home. Actually, let me just quickly refresh that because I did push up another change. There we go. I don't know if you've got it open, Pete.
Yeah, it should be running.
But if I do that, you see that the robot arm's moving. And we're moving the reach as well. And then we'll close that. Ooh. And Pete's doing it as well from his machine. So.
No, I think somebody else has logged in and they're trying it. They've spotted the web address and they're testing it.
There we go. So if I just drop back to that code quickly then. So we have there's 3 servos that we've got, and we're hiding the control when someone else sends a message so that they don't start interrupting each other as much. And then what we're doing down here is what we've got itself is we have our timers to do that disabling that we were talking about, and our hub connection. And we're doing pretty much the same as is on the firmware. We're going through that hub connection. We're connecting to the hub, and then on connection, we're doing the same sort of receive message action. But then we're also doing a couple of things for setting our servo, setting the UI controls as well. And then we have this state has changed option. Method, which is actually telling the UI that it needs to change and refresh, not necessarily the page, but just the DOM itself. There is our event for when the timer is expired, and we'll stop disabling the servo control. And then if I scroll further down, we actually have how we're updating the servo values themselves, and that's how we're sending the message over to the robot firmware. Now, obviously, this message has got to go somewhere in between, and that we've talked about hubs before. But what we've got in our server is the hub itself. So we've just got this chat hub, and it's as simple as this. So it has a send message. So when we receive the sent message from, say, servo 1, and I'm going to an angle of 90, then we'll receive that, and we'll send that message out to all other clients except for the one that is sending it. So everybody will see it. One thing, though, that we do with this is actually the web end we are deploying to Azure. We're going to deploy into an app service as well. And to do that, we're going to use GitHub Actions. So let me just quickly drop back into here. Oh no, it should be fine. I can just skip straight to that. There we go. But I do want that open. So what we have already is GitHub robot. Is I've got a fork of Pete's code that he did a little while ago, and then we've got and made changes to it. What we use to do our deployments is GitHub Actions. So if you're familiar with Azure DevOps already, this is basically the same thing. If I go to view our workflow file, you can see that all the steps we're running here are just defined as YAML. We're checking out our repo. We're setting up the version of .NET that we want to use, which is in our case .NET 5. We're running a clean in our working directory for the robot web. We're restoring our NuGet packages that we've mentioned throughout. Then we're doing a build, and then we're doing a publish. Then once we've published, we are deploying straight into our Azure web app. We've got our web app name, and we've got our publish profile that we're pulling in from a secret in the repo, and what package we're going to deploy to it. Now, obviously, you'll have seen here that these are just called Servo 1, 2, and 3, which isn't really that descriptive. So we're going to go ahead and make a change now, and we're going to push it back to GitHub, and we're going to deploy that out to Azure. So, Pete, you're going to have to remind me which one's which. I can't remember at all.
Yeah, so Servo 1 is rotation, I think.
Okay.
And Servo 2 is reach.
Rotation.
Yep.
So we'll rename both of those labels.
Mm-hmm.
I'm doing reach, did you say, sorry?
Reach, yep. Arbitrary names, but that's essentially what it's doing.
Yep.
And then the third one is whatever you want, grab, if you want to call it grab or something.
Yeah, let's call it grab. That sounds good enough to me. So let me just do a quick new terminal window to push that back.
Liam likes to do GitHub on the command line. I tend to use the GitHub extension in Visual Studio Code because I'm not quite as hardcore as Liam. Hey, look, I'd have finished by now.
Well, if you want to, you do it, Pete.
If you think you're that good.
Okay, so that's going to get pushed up now. So we've already got triggers so that when it goes to our main branch, it will already trigger a build. So if I go straight back into actions, you'll see already that is already running, and we can go into here and watch that happen.
This is very rudimentary DevOps, by the way. Well, and I mean rudimentary in that we've not put any gates into this, and any checks and any tests and any build passing checks and things like that for the purposes of demonstration. In reality, you most certainly would do, and you'd require reviews and all sorts. So bear that in mind, that you are watching the process here rather than the proper setup.
Yeah, we've skipped many steps here ultimately, but it will still do. It still does the job for us for now. You know, like we know that realistically we're going to want to get rid of that warning where we've got 2 unused variables. But for the purposes of what we're doing today, it's fine.
Yep.
So that is already down to the publish step. This is a lot faster than when we were doing a quick run through yesterday.
Yeah, thankfully. Those 2 variables, you can see, they're index.user input and index.message input, because if you follow any of the SignalR tutorials, then you will be creating a chat app. Mm-hmm. That is goes without saying.
I do have a blog article where we create completely serverless chat with Blazor and WebAssembly. So if you go to lgulliver.github.io, then you'll be able to see that in here, which I think but you started to work from this to start with, I think, for your...
No, I didn't. No. No, but I did come across it when I was searching on the internet.
Oh, yes. Yeah, that was it. Yeah.
Yeah, so no, I'd followed a different thing, but the fact that yours was serverless here is the difference. The tutorials don't do it that way. So
yeah, so when we were talking about Blazor WASM before with WebAssembly, that version, it uses I think it's using the Azure SignalR serverless option, and it uses a function app to do the negotiation. So that kind of server option that we were looking at in our code earlier is just sitting behind a function app for the hub, and then the front end just all sits in a static site host enabled storage account.
So that's fine. So it's not really serverless. We're lying to you. We're just making it look like.
Well, if you're putting it in the cloud, it's sitting on a server somewhere, isn't it?
Yeah.
Cool. So that's deployed. If I do Control and F5 for that, we can see all of that already. Now, I guess we're kind of at the point, folks, that if you want to, if you go to this URL,
I'm going to put it in the chat.
You can have a play with it as well.
I'll hold on to it. Now, the robot arm is a 3D printed robot arm that I found on Thingiverse. If you go to the GitHub repo that I'll also paste in the chat, my good friend Cliff Aegis and his son have created a far simpler 3D printed robot arm. There we go. People are moving it.
Cool. So if I go to, just close out of that. Oh, no, wrong thing. Yeah, so that's you guys basically controlling that arm in Pete's house in the middle of Leicestershire. You can see as well down this right hand side. There's all the message that are going through at the moment. It's holding up a lot better than when we wrote some code that didn't work yesterday, did it, Pete? When we crashed the whole arm.
Yeah, we did. Yeah, absolutely. So, I mean, this is relatively straightforward stuff that you're seeing here. Now that we've explained it, but it is the basis for real-time control SignalR. It is remarkably performant. The video that you can see there is actually OBS Ninja, which allows me to be able to share a URL with the code on it, with the display on it. So that's what you're seeing there.
So there's potentially real world applications for this sort of stuff as well, isn't there, Pete? Like there's, like we mentioned earlier, that remote surgery is a thing. Now this again, as is super rudimentary, and I really hope nobody uses our GitHub repo to make anything like that. But there's things like bomb disposal robots, or being able to clean gutters and that sort of stuff. It's all a good starting point. Because what we've written here is, like Pete says, it's really straightforward and really simple. Obviously, these real-world applications are going to be far more complex. But as a start of a 10, I mean, we spent maybe a couple of hours to get the UI to do the real time across multiple users on the internet. Pete, I don't know how long you spent in actually building the code for the firmware.
Yeah, let's not talk about that. It wasn't that hard, to be perfectly honest, because I've not made it super complicated. I probably spent longer writing the workshop instructions than I did writing the code that the workshop instructions help you to create. So in the GitHub repo, that once we've taken the robot offline and I can move my hand away from it, I was saying it's a bit, I don't know if you can see on that, if I can waggle that whole thing upside down, and if you extend the reach right out to 180 degrees, then it can come off its support. So I've got my finger on there just to stop it from falling over. I've given talks. I gave one at NDC, and at the end of that talk, I've got a blooper reel showing robot arms falling over while I was developing this. Yeah, so kind of someone's extended the reach all the way over there.
I think that it's probably worth talking about, actually. So these messages that we're seeing appear here, these are all those messages that are getting sent to SignalR. So we've got the servo that's being moved, so and then the angle. And we did want to figure out kind of like a challenge for everybody to try and do collaboratively, but we figured it might take some considerable time to be able to do to move something from A to B with everybody doing it. But like Pete said, what we'll do is we'll provide all the links to everything from the 3D stencils. Is it, Pete? STL files?
Yeah, absolutely. Yeah, the STL files for the 3D printed robot arm, and full workshop instructions taking you through, installing .NET 5 all the way through to controlling the robot arm are in there. I'm currently running a workshop with Cliff Aegis for the Microsoft garages across the world. So they're testing out the workshop as we speak as well. So that's going quite well. Paul's saying in the chat there, using this technology for use cases mentioned is fantastic. What about the obvious security concerns? In Liam's example, I believe, in his blog there, you can authenticate. So we can only allow certain users to connect with the right authentication credentials. So you wouldn't just open world this like we've done. you would go through an authentication procedure. Likewise, on the Blazor app that we've got there, we could use any form of authentication we liked, so that
you could tie them to stuff like YubiKeys and that kind of thing as well.
Yeah.
Obviously, don't do the accept all the certificates like we have.
For IoT applications, using certification is the best form of attestation for these things. So just use a TPM module. That's another really good way of doing it. So those sorts of things, there are a depth of information out there, wealth of information about IoT security. And yeah, people say S is the security is the S in IoT.
But when you've got, I don't know how it would apply here, Pete. But I know there's a Azure security based flavor of an OS for IoT devices, right? Is it like Azure Sphere?
Yeah, that's the one. Yeah, so they are tackling this from the ground up, and in fact, Azure it's got built-in security. So we're not tackling the Azure IoT side of things here. We're going straight through SignalR, but there's a platform called Azure IoT Hub that you can go through, and that allows you to ingress and egress messages in and out of Azure, millions at a time. And yeah, you can have security from SAS keys, SAS tokens, all the way through to certificates and TPM modules that way as well.
So folks, that's kind of the end of our talk. Thank you very much to listening to Pete and I talk through this. We've had a ton of fun building it, and there was many times where we went, "Holy crap, that works!" And we were really impressed with it. Has anybody got any questions?
I'm assuming that people can come off mute and ask now if they like. Certainly, I'd advocate that. Oh, we stunned them into silence. That's what
I mean, I'm just happy it worked when we did it live.
Yeah, exactly. Yeah, nothing broke, no one died, all those things.
Hi guys, thanks very much for that. It's really, really interesting talk, and it's nice to see some code up on the screen.
Yes.
So while people are hopefully thinking of questions and hopefully typing some in there, I just wanted to kind of start with a question, hopefully that will be, the answer will be interesting to our students. So we've got quite a few here tonight, I think, and probably quite a few first year students. So what advice would you have for somebody wanting to kind of start with IoT or with Azure? Where would be the best place to start?
That's two different questions, actually.
Do you want to take the IoT one and I'll take the Azure bit?
Yeah. I'll do a little bit of Azure as well. But absolutely, I mean, yeah, that's fine. So IoT wise, now it really just depends on what it is you want to do. But if doing cloud stuff is, you want to do the I part of things without actually doing the of things part, if you get me. So if building a robot arm really isn't what you want to do, you're more interested in getting messages into Azure to be able to analyze them. So I mean, the IoT Azure Hello World is temperature and humidity sensors. That's every single example seems to use those. And there's
except for that one thing from Future Decoded, what was about horny cows.
Yeah, that's a really good example, and we'll save that for another day. But there's a really good Raspberry Pi simulator, and if you just type Raspberry Pi, I'll put a link in the chat in a minute, but you can just type Raspberry Pi simulator Azure into Google, and you will find an open source Microsoft project there. It's all in Node, but it gives you a tutorial on how to get going with getting data into Azure. And that's a really good way if the Azure side of things is what interests you. But if building the thing is what you're interested in, then there's a fantastic free tool called Tinkercad Circuits. It's made by a company called Autodesk, who make AutoCAD. And it's a circuit playground. And I'll put the link in the chat. But what's great about that is you can drag an Arduino onto that circuit playground, and you can connect components to it, and then write the code and run it directly in the circuit playground. It's a fantastic tool. It is really worth checking that out. And that gives you the things part. What is really sad is that there's no internet connectivity in that Tinkercad application. It's all online. It's a web-based application. They took that out recently because I think people were using it for nefarious reasons. So there's no internet in that, but it's great for Arduino programming. And what's great about that is that you can download the code and just run it on a real Arduino afterwards once you've got it working. The other good thing about it is that you can program an Arduino in a Scratch block-based language to begin with. Now, if you're a beginner, so you're not a programmer at all, doing C, which is what you traditionally be programming an Arduino with, is difficult. C is hard when you want to do anything complicated, but dragging blocks onto a screen is child's play almost. And then you can convert that block-based language back into C, download it, run it up in Arduino Studio on your local machine, program it into a real Arduino, and it will just work, assuming you've connected the components correctly. So that sort of answers those two questions there. And Liam, do you want to talk about how you get into Azure?
Yeah, I mean, I guess so coming from the point of view of how I did, for me, what I actually started doing was before all of these great resources that exist today, I didn't have the luxury of things like Microsoft Learn, where they've got tons of free resources and exercises you could go through to go and do things now. And there's a bunch of quick starts as well. But from my starting point, I originally, as a software developer, I just wanted to move stuff up into the cloud, and I took something I'd built and said, okay, well, how do I put this somewhere else? Because I don't want a server running in my house. I don't want to pay for a physical box somewhere. How do I take this and put it elsewhere? I would take, these days though, literally I would go down the route of, let's start with the Microsoft Learn side of things.
Yep.
Because they go from the basics all the way through to some fairly advanced topics as well. They're not necessarily all how does this apply in the real world? But there's a lot of once you've gone through that sort of Microsoft Learn piece, if you wanted to, you could go down the certifications route as well, and that can show you a lot of those things. And then there's also a lot of really great video resources as well through things like Pluralsight and so on too.
Yep, true. I agree with all of that. In the interest of time, Ashley Harris has asked, at what point does IoT become an electrical engineering discipline? And for a computer student, how would you tackle this? I tackled it by doing electronics and electrical engineering at university. But I specialized towards the programming side of things. So I got both. I mean, I was doing my GCSEs and I looked at A-levels, and physics was as close as I could possibly get to doing this sort of stuff. And there was next to no programming in that. So I wanted a discipline where I was hands-on. So I went to college and did an HND, and then I went to university afterwards with electronics engineering. So I have that background. But you're right, for people that are perhaps doing CS rather than electronics, then that is a bit of a hill to get over. The good thing is, for the most part, you can do very little damage to these sorts of things. And if you do, it's 30 quid. And I know it's still money, but it's not hundreds of pounds you're going to blow up like a PC, for instance.
Well, you could even start with smaller, couldn't you? Like with the Pico, which is what, 4 quid?
Exactly, that's right. Now, as I mentioned earlier, there's something called Tinkercad, and that is fantastic because you can just drag those virtual components onto that workspace there, hook them up and see if they run. And if they don't run, then you don't get that magic blue smoke coming out of your components that you bought. You can just play with them there. Now, what's even more cool about it is there's a bunch of lesson plans that you can run through, and they teach you about how this works, all the way from LEDs and buttons all the way through a bunch of other stuff. So again, once I finish talking, I'll stick the links in the chat, and it's well worth checking that out. It's all free. Karish Patel has asked, what is the industry perspective to such an application IoT, and how do you think the industry corporates will take advantage of such?
It's quite big in manufacturing, isn't it?
Yeah, absolutely. I mean, funnily enough, Liam mentioned cows earlier, and I've not got time for the full talk, but IoT is used heavily in agriculture and that industry because there's a lot of manual intervention required. And cows, they get pregnant by means of not putting a bull in a cow and in a field anymore. There's a methodology that they use, and they have to use this methodology at exactly the right moment in time. And so a cow is what's called on estrus at a particular moment in time. And it was a very manual process of watching the cow to figure out when it was on that particular moment in time before.
A lot of that time, wasn't it?
Exactly. So they strapped Fitbits to cows, and they watched their numbers of steps, and they could use predictive analytics then to figure out the best moment in time to strap things to do things to cows to make them pregnant.
To do things to cows.
Exactly. I don't want to go into too much detail, but what was really interesting is they found things out from that data where if they made a cow pregnant a couple of minutes before this perfect time, or a couple of hours rather, you would get male cows, and a couple of hours afterwards, female cows. And they could also find cows that are moving around during pregnancy. If they were having a troubled birth, they could alert farmers to that. And they also figured that there was like 7 or 8 different diseases that they could pick up just from the cow moving around, and by placing sensors on other parts of the cow, let's say. So yeah, things like robot surgeries, which are a reality now. That is another far extrapolated version of what we were talking about here, and robotic bomb disposal equipment, and then instrumenting everything. So there is a lot of money in IoT because we're able to instrument and get data, and data is very valuable.
Yeah, and I guess there's the other bit that sort of sits on top of those last couple that you were just saying, Pete, where they start to work hand in hand with things like mixed reality through things like HoloLens and that kind of stuff too.
Yep, precisely.
Well, we haven't bought one of those yet, so.
Yeah, I need to just buy one. It's a tax write-off. Any more questions, anyone? Oh, the possibilities going forward are limitless. Could you add an Azure Sphere microcontroller to secure the ARM? Yeah, absolutely you could. Obviously, I mean, I could add certificates to my Raspberry Pi and use certification as a perfectly valid form of authentication there. That attestation methodology is well supported within Azure, and SignalR supports that. As you saw, where I was allowing any certificate, I could actually just trust a certain certificate, leaf certificate from a GA there somewhere. So yeah, we could absolutely do that. Really interested to get more information about Tinkercad. Yeah, I'll stick that link in the chat.
I think there's also some really good sort of basic examples of IoT in most people's homes these days as well. From, you know, if you've got an Echo device in your house and some smart lights, you know, they're working on similar microcontroller principles of if this then that, based on a command over the internet or over your local network. It's the same sort of principles.
Yep, I've done a talk on controlling like smart plugs, making your own smart plug with the Raspberry Pi, using the AWS stuff. I don't have to do a massive amount on AWS, but the Alexa stuff is pretty cool. So yeah, there's that.
All right, I think that's it. We've run out of time. Thank you very much, Peter and Liam. This has been an excellent session, and want to thank everybody for attending and joining us today. Please remember that on the 15th of March, we will be holding our next session, which is an introduction to IT strategy with Wardley mapping, and that will be delivered by Mike Haber. Once again, thank you very much, everyone, for joining us, and have a good evening. Bye.
Cheers, thank you, bye.
Thank you.
Thanks, Peter. Thanks, Liam.
Thank you.